Yes, Ajay. Now, can you audible?
Yes, sir, you're audible.
Okay.
Yes, sir, you're audible, sir.
Yeah. You got the last problem, or where I exactly that connection is disconnected? If in which step? Have you got this answer?
So could you explain that last part again, sir?
That is second refraction, right?
Yes, sir. The first refraction we understood, sir, but the second refraction on which your voice also started breaking, screen also
Okay.
started lagging, sir.
Yeah. Okay. So in the first refraction, where the image is going to be formed, this in the first refraction, the image is going to be formed at a distance of 9r. Wait, I will erase and I will rewrite. For the second refraction, which will be the object?
So
V dash will be the object, right?
yes, sir.
Yeah. For that V dash, in which medium it is? It is in glass.
Glass.
Yeah. So how to write the equations for that? So N1 is the object medium, right? So for the second case, object is glass. What is the refractive index of the glass? 3/2. By which is the object for the second spherical surface? This 9r is the object, right?
Yes, sir.
Yeah. So minus 3/2 9r plus what is N2 value? That is the refractive index of the image medium, that is in air. So it is 1. Which is the image distance you have to find. N2 value is 1. N1 value will be 3/2. Whole thing divided by the radius of curvature, that is minus r. Why radius of curvature is minus here? Because that is taking opposite to the incident ray, right? Incident ray is moving towards the right side. Incident ray is moving towards the right side. But the radius of curvature is measured opposite to that. So it will be equal to minus. So minus r. Now this will be minus 3/9 into 2 will be 18r plus 1/v is equal to, what is 1 minus 3/2? Minus 1/2, no? It is minus 1/2
Yes, sir.
by
Yes, sir.
minus r. So this minus and minus will get cancelled. This will become 3 6 18. So minus 1/6r plus 1/v is equal to what? 1 divided by the 2r. So what is 1/v from this? 1/2r. If I shift 1/6r with negative sign towards the right side, it becomes plus 1/6r. So what about the LCM? 6r. So it will become how much? 4/6r, no?
Yes, sir.
So what is V? 6r by 4. What is 6r by 4? Three r by 2. So exactly where the final image is going to be formed? Final image is formed where? 3 by 2r. So which is the right option? Option C. 3r by 2 is there. Got it?
Yes, sir.
Yeah. So these are the problems on refraction through spherical surface. So the last unit in ray optics that is optical instrument. Yeah. Yes. You can see the screen sharing of optical instruments.
Yes, sir.
Okay. Now this is the last part of refraction, Ajay. And in this optical instrument, we are going to analyze the two concepts, that is the microscopes and the telescopes. After analyzing this microscope and telescope, briefly let me explain the concept of the human eye, that is, and also the defects of the eye. That is not there in the syllabus. They have deleted that, but still let me know, because in competitive they may ask the question based on the defects of the eye. Now, before going to define the concepts of simple microscope and the telescopes, let me know what is the meaning of the magnifying power M. What is the meaning of the magnifying power M? Now, let us say there will be a convex lens here. Okay, there will be a convex lens. Now, I am going to place the object somewhere here. If I place the object here, for this object, there will be an image, right? Let us say the image is going to be formed here. This is the image. I. So, keeping the eye at the optic center, if I draw the image, somewhere you are going to get here. So, this is the ray for the image. I will consider this angle as beta. Now I am going to drop one perpendicular line from the object. From the object, I am going to drop one perpendicular line. From this, there will be an angle formed at the object. I will take this angle as alpha. This is alpha. This is beta. This ratio beta by alpha, is what we called as the magnifying power. So magnifying power is the angle of the instrument divided by the angle of the object. That ratio is what we called as the magnifying power. Got it? Or you want another example? Look at this. This is a convex lens. This is the principal axis of the convex lens. If I place the object here, you're going to get the image somewhere here, right? this is object, this is image. Now, from the optic center, you just draw the line to the image. This is the image where it is going to be formed. Now, this is the angle subtended by the instrument. Because of the instrument, because of the lens only, I am getting this image, right? The angle made for the image by the instrument at the center, I will denote that angle as beta. That angle as beta. Now, I am going to draw another line perpendicular like this. From this position, I will calculate one more angle. I am going to calculate one more angle of the object. That angle is what I am going to denote with alpha. So beta is the angle made by the instrument. Alpha is the angle made by the object. That angle ratio beta by alpha is what we call as the magnifying power. So magnifying power is the ratio of angle subtended with instrument or with lens to the angle subtended by the object. This ratio beta by alpha is called as the magnifying power for the instruments like microscopes and the telescopes. In microscopes, we have two types of microscope. One is called the simple microscope. The second one is called as the compound microscope. Now, in the simple microscope, we are going to get an enlarged and erect image. In the simple microscope, we are getting an enlarged and erect image. It is virtual and it is enlarged. No doubt it is erect image. It is not an inverted image. In the simple microscope, what is the nature of the image, Ajay?
So,
in the simple
it's
microscope,
a virtual and enlarged image.
it will be virtual, it will be enlarged, and it will be erect. And
Yes, sir.
one more thing you have to observe. One more thing you have to observe here, where the object is going to be placed. Where the object is placed. Can you tell me, Dhanlakshmi, where the object is placed? Look at the diagram.
So between F and O, sir.
Yeah, that is the concept here. Between the principal focus and the optic center, you have to place the object. Because in the case of a convex lens, to get a virtual image, this is the only a position. To get the virtual image, you have to place the object between the principal focus and the optic center. So that is the main principle of the microscope, simple microscope. So in the simple microscope, we are just using a single convex lens of small focal length. And this simple microscope is also called a magnifying glass or a reading lens. In the simple microscope, object is going to be placed. Object O is placed between the principal focus and the optic center. Now, can you tell me the beta and alpha value for this? This is the beta, right?
Angle AOB, sir.
Yeah, this
So
angle
A
AOB.
dash OB, sir.
Yeah. Now I'm going to drop one perpendicular line like this. And I'm going to drop the angle from this particular point to the optic center. This angle is what we called alpha.
Alpha, sir.
Now, how to find the magnifying power for this? It is nothing but beta by alpha, right? Beta divided by the alpha. And if this beta and alpha are very small, I can take beta as tan beta and alpha as tan alpha. And if I substituting that trigonometry over here, finally I am going to get the formula here. Please remember this. What is the magnifying power when the object is placed at the least distance? When the object is placed at the least distance, the magnifying power is given by the formula 1 plus d by f. What is this d? That is, d is called as the least distance of distinct vision. Least distance of distinct vision for normal human eye. For normal human eye, the least distance should be a 25 centimeter. If the human eye is going to use the object less than 25 centimeter, he cannot get the correct proper cleared image. In order to get a cleared clarity image, the person has to keep the object at least at a minimum distance of how much? 25 centimeter. That is called the least distance of distinct vision. If you place the object at that distance, then the magnifying power of the simple microscope is given by 1 plus d by f, where f is the focal length of the convex lens, d is the least distance of distant vision. Suppose if the object is placed at infinity, if the object is placed at infinity, where the image is going to be formed? The image is going to be formed at f only, but only the thing the object is placed at infinity. In that case, please remember the magnifying power of the simple microscope is given by d divided by f, and that is the minimum value. And this is the maximum value. So what is the formula for the magnifying power of the simple microscope? Magnifying power for the simple microscope is given by 1 plus d by f. What is the magnifying power formula when the object is placed at infinity? When the object is placed at infinity, the magnifying power is equal to d by f. These are the two formulas for the magnifying power of the simple microscope. Got it?
Yes, sir.
Yeah.
Yes, sir.
Now, what will happen if the object is placed beyond the principal focus? What will happen if the object is placed beyond the principal focus?
Image will be formed at infinity, sir.
No. The image will be formed at infinity when you place it exactly at the principal focus. I am telling beyond. For example, if I say this is the convex lens, this is the optic center, this is the principal focus. If I keep the object on the principal focus, the image will be formed at infinity. I am telling that the object is placed here, beyond f. In this case, if this is the object, the image is going to be formed this side, and it is an inverted one. It is an inverted one. You got my point?
Yes, sir.
Yes, sir.
Yeah. But in this case, the image is not a erect one. It is a enlarged and it is a inverted one, right? It is not erect. It is a inverted one.
Yes, sir.
Yeah. Now, if I place one more lens here, if I place one more lens here, such that this image should be the position between the optic center and the principal focus of the second lens. Please analyze properly here. I am placing the second lens in such a way that the image formed by the first lens must occupy between F and O. Between F and O. In such a way that I am placing the second lens. I am keeping the second lens in such a way that the image should occupy the position between F and O of the second lens. You got my point?
Yes,
Yes,
sir.
sir.
Now, can you tell me where the image of this is going to be formed? It is a real or a virtual? First, you tell me that.
So virtual.
Yeah, virtual means it has to form on the same side, right?
Yes, sir.
The image is on the left side. So the virtual image of this should be lies on the same side that is going to form here. So this is the final image I'm talking. In this, it is very, very enlarged, but with respect to object, it is not a erect, it is a inverted one. It is a inverted one. You got my point?
Yes, sir.
So in the second case, we are producing a inverted image. No doubt it is a virtual only, but it is not a erect. It is a virtual image. It is a virtual image, but it is very enlarged. To get this, how many lenses we are using?
2 lenses, sir.
2 lenses we are using. If you are using this type of microscopes, we will call this type of microscope as a compound microscope. So only the difference is, in the simple microscope, we are using only one convex lens and we are placing the object between the principal focus and the optic center. But in the case of the compound microscope, we are using the 2 lenses, but the object is placed beyond the principal focus of the first lens. What is this difference between simple and compound? In simple microscope, whatever the image you are getting, it is a virtual image, it is a erect image, it is enlarged. But in the case of the compound microscope, image is very, very, very enlarged. It is a virtual image, no doubt, but it is not a erect. It is not a erect. It is a
Inverted.
It's inverted.
It is an inverted image. That is the main difference between the simple microscope and the compound microscope. You got an idea?
Yes, sir.
Okay. So I will stop at this stage, Appa. In the next class, we'll continue with the compound microscope and telescopes. Okay.
Yes, sir.
Thank you, Appa. Take care. Bye-bye.
Thank you, sir.
Thank you, sir.